this lesson, we'll be graphing our systems of inequalities with parallel lines. So you will explore solutions using technology and understand the special cases for parallel lines. And we'll graph them using real-world problems. So a solution to a system of inequalities means that the region is where they overlap. So it's kind of like our and compound inequalities, because it's where the solution is where they overlap. So when we do the same thing on a coordinate plane, when we're shading our inequalities, where do they overlap? So we have special cases when the boundary lines are parallel, because the solutions may be between the lines, like this. So one of the shading would be above and one of the shading below, and so the shaded where they overlap is in between the two lines. It might be above both of them, but the shading doesn't start until the second line. Or each one would shade the opposite direction, and so there would be no overlapping areas. So let's try some examples. This first one just says, which quadrant is the solution to this systems of equations? So we have y is greater than -1, so that means our shading is up here, all the way in here. And in this one, x is less than 2y, our shading is down here. So they overlap right in here, which is quadrant 1. All right, graph the systems of inequalities. So in this first one, we're going to begin at -3, and then we're up 2, right 1, up 2, right 1, up 2, right 1. Our line is dashed, and our shading, 0 is less than 0 minus 3. So 0 is less than -3. No, 0 is not less than -3. So our shading is over here. In the second one, it starts at 2, and it goes up 2, right 1, up 2, right 1. So these lines are parallel. And this is also dashed. And so it says 0 is greater than 0 plus 2. 0 is greater than 2. 0 is greater than 2. No. So that means it's shading over here. So where do they overlap? They don't. So there's no solution. All right, let's try this one. So we graph the first one. It starts at -3. No. Yes, sorry. Up 1, right 1, up 1, right 1. And this is a dashed line. 0 is greater than 0 minus 3. So 0 is greater than -3. No. 0 is not greater than -3. So that means, no, yes, it is greater than -3. Sorry. Oh my goodness. All right, so we're going to shade up there. Second one starts at 1. And it also goes up 1, right 1. So we've got parallel lines. 0 is less than 0 plus 1. 0 is less than 1. So yes, here's my line. So this shading is down here. So where do they overlap? They overlap right here in between. All right, graph the systems of inequalities. So the first one, we're going to begin at -2 and go down 3, right 1, or up 3, right, left 1. And this is a solid line. And our shading, 0 is less than or equal to 0 minus 2. 0 is less than -2. No. So our shading is over here. Let's graph the second one. It begins at 4 and down 3 over 1, down 3, 1, 2, over 1, 1, 2, 3 over 1. Okay, and this is a solid line as well. And let's plug it in. 0 is less than or equal to 0 plus 4. 0 is less than 4. Yes. So we are shading here And so where do they overlap? They don't overlap until they're this way. All right, true or false? Parallel lines never have a solution in a system of inequalities. And that's false. We could have a system, we just have to have the shading overlap. The solution set is where the graphs do what? It's where they overlap.